Okay guys, in this video lesson we're going to dive into the different types of forces that we're going to see throughout this unit. Okay, the first force and probably the most important one is weight. Alright, that is actually the force of gravity pulling on us. This is not mass. Mass, remember, is kilograms, or it is the amount of matter in something. This is measured in newtons, and it is basically what gravity does to us or any other object is our weight. Now, nice thing about weight or the force of gravity is it always pulls straight downwards. Okay, so if you're writing some notes here, I would kind of make a vector arrow pointing down with that, because the force of gravity is always pointing towards basically the surface, or towards the center of our planet, which is always downwards. Okay, most important one is probably weight. Second most important force to probably deal with is the applied force. So as we move objects or accelerate objects or change the motion of objects, to do that we have to apply a force. Okay, that applied force could counteract weight, or it might work with weight actually. Okay, so anytime we apply some sort of external force on an object, we call that the applied force. Symbol we use for that is F sub A. So these are all going to be F's for forces, and then the little subscript is going to tell us what type of force it is. So here's gravitational force, or our weight. Here is the applied force that we have as we take a look at it. Okay, these can be contact forces, or they could be field forces. Either one would be considered an applied force. Now we have the normal force. So the normal force is this force that happens because an object is sitting on the surface of something. Okay, so for example, we have a tire here sitting on a brown mat. That tire isn't flying downwards, it's not flying upwards, it is stationary. So it is stationary because gravitational weight is pulling it down, but whatever this mat is made of, this brownish kind of mat, has to be strong enough to push back or fight against that gravitational pull. Okay, and that we call the normal force. Now, you see a little T here, don't worry about that. What we do is we use the F sub n to solve for our normal force. Okay. Now, the object is on a horizontal surface. So if this is horizontal, or a flat surface like this, they're going to be opposite of each other's. Notice it's only if it's horizontal. Okay, so underline that or highlight that kind of idea. Okay, because over here, if we take a look, if we have an object sitting on an inclined surface with an angle to it, the normal force is always perpendicular to the surface. Okay, so that's kind of our definition of the normal force. It's a force generated by the surface of an object holding something up. It does oppose gravity. However, it must always be perpendicular to the surface. So in this case, the normal force and the weight this object feels are not opposite of each other. Now, the reason why this might not be sliding down the ramp is because there's friction also on that ramp holding it up. Okay, and we'll talk about friction in a minute. Okay, it is nice though when they are horizontal, because then we can say the normal force is equal to the opposite of our gravitational force. So often when we do calculations with what our weight is, or how much something weighs, what we're really solving for is that normal force. So basically, what is that opposing force that holds us up, even though gravity is pulling us downwards? Okay. Another way of saying it is that the normal force is a positive Fg for horizontal surfaces only. Okay. Now we have friction force. Now, friction force is applied always in the opposition of motion. So as something moves, for example, if I'm moving, pushing my lawnmower, mowing my lawn, like I did this weekend, okay, the friction on those wheels, the friction of the grass against the lawnmower, okay, that is all pushing in reverse, okay? It's always in the opposite of my motion, okay? Now, friction doesn't mean it's always going to be slowing you down. Remember, friction can also start you. So think of a sprinter coming out of the blocks at track. Think of a car taking off from a stoplight. Those wheels are spinning in one direction, and if there was no friction, the car would just sit there and spin. Okay, the wheels actually pull backwards on the concrete. That creates friction, and the friction actually forces the car to move forward. So friction can be seen as something that slows us down or stops us, but it can also be something that's needed to start us moving forward also. Okay, but it will always oppose motion. So whatever direction that you are moving in, or the object is trying to move in, it's going to be the opposite of that direction. Okay, so it's going to have that opposite sign as we take a look at the forces acting on things. Okay? Now, One particular type of friction force we want to talk about is air resistance, also known as drag. Okay, so air resistance is a friction that happens as we try to push an object through the air in our environment. Okay, um, what happens is as you drive a car, there's air here. We don't see it. We walk through it. We don't really notice it unless it's a windy day. But as that car tries to drive through this stagnant air, this stationary air, it hits the windshield, it hits the bumpers, it hits this whole thing, and that is force that acts against it. So the car has to push through that air. As it does that, it actually resists that motion. So it's a type of friction. So we have air resistance as one of our types of frictions. Okay. Another example of that would be like skydivers. Skydivers jump out of a plane and they start to accelerate very quickly to the to our planet. But as they accelerate, their friction force or their air resistance also begins to increase. So the increase in air resistance continues until it matches the gravitational force, and that's called terminal velocity. So things can actually, they fly at a certain speed until they hit their parachutes and that kind of stuff. Okay. So we don't often include air resistance in our math, but in this unit there will be times that we're going to talk about the friction against something, and there could be air resistance there that we actually include in our math. Friction we all the time symbolize F sub Fr. Sometimes you'll just see FF, you won't have C or the R on it, but it kind of means the same thing. Now, the last type of force we're going to talk about is tension. Okay, so you also get a force from basically objects pulling on each other through a rope, a string, a cable of some sort. It's often seen in a scenario where we're using pulleys, or we're hanging something, or something is suspended from a hook of some sort. So a lot of times we see it in the world of vertical motion as we look at tension. Okay. Um, in this case, when you have tension, what happens is you actually have the force in the same in both directions. So if this hand is pulling at 10 newtons of force and this hand is pulling at 10 newtons of force, the overall result here is they have the exact same amount of tension on them as they both pull. Okay, this hand can't feel more force than this hand feels. They both are feeling 10 newtons of force as they both pull. Okay, which means if you have two blocks here, if block A is 5 kilograms and block B is 5 kilograms, okay, this pulley has to be strong enough to hold 10 kilograms because it's feeling 5 from this side, it's feeling 5 from this side, so it has to be strong enough to hold the weight from both sides for that thing to actually work. Okay. Now, one thing we do make sure that we talk about is that the rope or the cable itself, we assume it's massless, okay? Because if not, then we have to add in the mass of this and what percentage is being held over top of here, what percentage is under tension. It makes it a little bit trickier, okay? So what we do is we assume the rope that's holding it is massless, so then we can exclude it from our math, okay? As we take a look at it. Tension is often used as we hang a mass and deal with what happens as that occurs, okay? And we symbolize it F sub T, as you'd expect, as we do that. Also, tension tends to be a stagnant or a stationary or a static type of scenario. We'll deal with later on what happens when the pulley starts to move and spin. But for now, we're going to deal with tension most of the time as something that's just hanging still, and basically the weight that's on that object and how much tension has to be there to counteract that weight. Okay? All right, guys, that is the end of this idea of the different types of forces. In our next video, we'll talk about force vectors and how they can apply to help us diagram out what's going on. Thank you.